Hello, and welcome to a video on the sum and difference of cubes. So this is a review, but I'm going to show it to you as if you've never seen it before, so we'll just start from scratch. So these are the two formulas for the sum of cubes and for the difference of cubes. Now, unlike with squares, there is a formula for both. With the difference of squares, there's a formula for the difference, but there is no sum of squares formula for factoring. You can't factor a sum of squares. Now let's first kind of take a look at one of these formulas. Let's look at the sum of cubes, and let's just make sure that it works. So what I want to do is I want to multiply the right side and see what I get. Okay, so I'm going to distribute the a first. So a times a squared is a cubed. A times negative ab is negative a squared b, so minus a squared b. And then a times b squared, so plus ab squared. I've distributed the a. Now I'm going to distribute the b. So I get plus ba squared minus ab squared, right? B times negative ab is ab squared. And then plus b to the third. Now let's look at our terms here and see if we get any cancellations. You got to look really carefully because they really kind of look the same. You have a negative a squared b there and a positive a squared b there, so they cancel. You have an ab squared there and a negative ab squared there, so they cancel. So all we have left, a cubed plus b cubed. So the formula works. Okay, and so does the other one. I encourage you to test that one out as well. All right, so how are we going to use this? We're going to take a sum or a difference of cubes, write them as things that are cubes. So this one would be x cubed, and this would be, think about it, what cubed equals 64? And it's 4 cubed. Now it's going to help you if you kind of get a little bit familiar with the first 4 or 5 cubes. You don't really have to know more than that. You'll have a calculator. You can always test it out. But 4 times 4 times 4 is 64. All right, so this would be like our A, and this would be our B. And we're just going to apply the formula right there. Now, the way that we think of this formula, notice what this is when we break it down. We have an A cubed and a B cubed, and it starts out with A plus B. So the first is a binomial just without the cubes. The second trinomial has the a squared at the beginning and the b squared at the end, and in the middle is the product of a and b. Now we have this little mnemonic device, which is SOAP, which stands for same, opposite, always positive. So let's look at this. So we have, this is a plus, this is also a plus, so that's the same. This is a minus, that's the opposite of the plus, right? And this one is always positive. And here it's a negative, and it's same, opposite, and still always positive. All right, let's apply this one and see if we can factor this completely. So we have a and b, and we're going to put the x and the 4 at the beginning. X plus 4, actually, because whatever this is, it's going to be the same in the first. Now the trinomial is the one that we have to put the x squared at the beginning and the 4 squared at the end. It's going to be 16. And then in the middle is the product of the two, so that's 4x. Now we go ahead and we apply that mnemonic device. This is plus, so it's same, opposite, and then always positive. Okay, and there it is, it's factored. Now we can just rewrite this as a 16 and we're done. So this would be x plus 4 times x squared minus 4x plus 16, and there it is. We have now factored a sum of cubes. Okay, let's try a difference of cubes. Now this one's a little bit more involved because what's being cubed here is x squared, right? So this is x squared cubed minus 1 cubed. That's a 3. So we're going to apply the same rule. So these are like our a and our b now. And then this one, it doesn't matter. These are both the same, right? They're both really laid out the same except for the SOAP part. Same, opposite, always positive. So I'm going to lay them out the same way. So I'm going to start out with an x squared and a 1 and then I'm going to put the square of that, which is x to the fourth. I've got to be careful when we have higher degrees here, but this is x to the fourth. The square of that, which is 1, goes on the outside. So 1. And then the product of these two goes in the middle. So that's going to be an x squared. Now, this is negative, so it's same, opposite, always positive. Now this one can be factored further. This is the difference of squares. So to finish this, it would be x plus 1, x minus 1. And a little clue here, the trinomial that you get when you use this formula for sum or difference of cubes, that trinomial can never be factored. So this is it. X to the fourth plus x squared plus 1. There it is, fully factored. Okay. Let's go on and look at one where we're solving. So now let's see, we can first take the x. First take out the x, factor it out. So we have x times x to the third plus 125 equals 0. Now we recognize this, hopefully, is the sum of two cubes. This is x cubed, and this is 5 cubed. So I'm going to have that x out in front. That x is just being carried down. This would be my binomial, x and 5. And then my trinomial will have the x squared at the beginning, the 5 squared at the end, and the product of x and 5 in the middle. Now, same. This is a plus, so it's going to be same, opposite, always positive. We don't really need those outside brackets. It just helped us sort out the middle part, but now we can set our factors equal to 0. Now we're solving over real numbers, and let's see what we get here. So we have x equals 0. That's already done. We have x plus 5 equals 0. That just requires a simple step. X equals negative 5. And over real numbers, this has no real solutions. So if I set my other factor, and again, this can't be factored further, but if I set that other factor equal to 0, x squared minus 5x plus 25, you can either trust me or test it out by trying to use the quadratic formula. You won't be able to factor it, but this has, when I try to set that equal to 0, I will find no real solutions. No real solutions. So this trinomial will never generate any more x-intercepts. And our only real solutions are 0 and negative 5. The last kind of factoring is quadratic form. And quadratic form is just a more advanced version of using of the different methods that we have for factoring quadratics. Now, an example of a quadratic form is actually the example that we looked at right here. We looked at it as a difference of cubes because that was what the focus was up here, but we could also write this as the difference of squares, right? We can write this as x cubed squared minus 1, and we could have applied that formula as well. So we're not going to do that. We're going to go on and look at some other possibilities for candidates for quadratic form, but we could factor this as the difference of squares. All right, so let's see what we have here as a first example. Now, when you have a trinomial, a little clue is, when is it in quadratic form? Whenever the leading term is twice the degree of the middle term. That is what happens with the quadratic, right? The leading term is second degree and the middle term is first degree. Well, here, the leading term is fourth degree and the middle term is second. So this should work. Now, here's what we're going to do as a little, now some of you can see this without doing this, but this is good practice actually for what you guys are going to do in calculus. We're going to take that middle term, the variable, and just let that be u. We're going to call that u. It's called a u substitution. They're very common, and this might be your first time seeing it, but it's pretty helpful. So we're going to say u equals x squared. It's always going to be that middle term. It follows that if u equals x squared, then what would u squared be? Well, you have to square both sides, so it'd be x to the fourth. Now we're just going to rewrite this with u's instead of x's, and we will then have a quadratic. You can only do this. This will only work if your original function were in, or equation were in quadratic form. So watch what happens. X to the fourth turns into u squared minus 3x squared, well, x squared is u, so minus 3u minus 54 equals 0. Look at that. That's amazing. It's just a quadratic. We can solve that by factoring, normal way of factoring. So we have, we can make whatever method you have. I'm just going to use, I'm just going to write it out. So u and u. We need a product of negative 54 and a sum of negative 3. And I believe that negative 9 times 6 will work. So minus 9 plus 6. So if we multiply that back out, we would get a minus 3u in the middle and a minus 54 at the end. All right, now we don't really want to solve this for u. We want to solve it for x. So once you've used the u to sort of see it a little bit more clearly as just a regular old quadratic that you know how to factor, you go ahead and replace u with x squared. So this is really x squared minus 9 times x squared plus 6 equals 0. And we're on our way to solving this and figuring out what the values for x are. We can finish solving this. It's a difference of squares, x plus 3, x minus 3, and then we can't do anything with this, and we can't factor a sum of squares, so it's times x squared plus 6. And when we want to solve that equaling 0, we said each factor equal to 0. So we go x plus 3 equals 0, which means x equals negative 3. We go x minus 3 equals 0, which means x equals positive 3. And we go x squared plus 6 equals 0, which has no real solution. And we look at the directions, because that will matter here. And since the directions ask us for the real zeros, we only want the real, not the complex, we're going to stop there. We don't need this because it's not going to generate. There's no real zeros coming from that factor. Okay, so our solution would be x equals plus or minus 3. All right, let's try one more. We're going to this time first factor out an x. Okay, so there it is again. The middle term is half the degree of the first term, so this inner part here is in quadratic form, so I'm going to go ahead and factor that part right there. So I'm going to let u equal x squared. U squared equals x to the fourth, same as before. Replace them. I'm just focusing on this trinomial right now. So I have 5u squared plus 3u minus 8. I'm going to factor that by guess and check because the first term is prime, so I know that there's a 5u and a u. That's the only possibility, and I want to have a positive 3 and a negative 8, so I'm going to put an 8 and a 1 here. If I put the 8 here, I get a 40, so I'll put the 8 here, and I want the 8 to be positive and that to be negative. Now this is really the x's, so I'm going to carry down the x. So I have x times 5x squared plus 8, I just replaced the u with the x squared again, times x squared minus 1 equals 0. Before I do anything else, I want to fully factor. I know that this can be factored more. So I have x times 5x squared plus 8 times x plus 1 times x minus 1. And that equals 0. I look at each factor. This one is going to give me x equals 0. That's one of my solutions. This one, if I go x squared plus 8 equals 0, and I try to solve that, I get 5x squared equals negative 8. X squared is equal to a negative number, which means I'm not going to get any real solutions out of that. Now it's important at this point that you look at the directions and you see, do you want the complex solutions or just the real solutions? So in the directions, it says only the real numbers. Solve this over the real numbers. So we're just going to stop with that. So this is no real solutions for this part. This factor doesn't give me anything. No real solutions. So then I go on to these two. I have x plus 1 equals 0, so x equals negative 1. I have x minus 1 equals 0, so x equals 1. And those are my three solutions. Okay, I hope you found this helpful.